There is quite a lot of prep work to get this set up, and rather than dig into every detail, I'll explain the scripts I wrote to help speed things up. Let's assume our Kubernetes cluster has been built and has worker nodes correctly registered. Everything has been set up in AWS already. This clip focuses on the client-side setup. I've created a new Kubernetes directory that contains relevant bash scripts and manifest files. The first script we'll explore is install Kubernetes packages.sh. This script installs two key packages needed to interact with an AWS EKS cluster. I've broken the script into two main parts. First, we install kubectl, a command line utility that simplifies interaction with the cluster. These commands are copied almost exactly from the referenced documentation links. I'm declaring a variable named k just to reduce the length of the curl command on line 8. This variable also makes it easy to choose a specific kubectl version. After downloading kubectl, we ensure it is executable by adding the execute permission for all users. Then, we move the executable into a location already included in the shell path. Then, I print the version information just to make sure it was successfully installed. Next, we need to install another binary called AWS IAM Authenticator. IAM stands for Identity and Access Management and is the AWS service for managing users and groups. This is used behind the scenes to provide authentication for EKS interactions. The installation process is conceptually similar to kubectl. First, we download the binary and make it executable. Then, we move it into a location where Bash will see it. Last, we print the version information and ensure a successful installation. To verify that our dev box can talk to the cluster, we use the AWS STS getCaller identity command that reflects back our IAM username. The update kubeconfig command automatically configures kubectl to connect to the cluster named globocluster based on the AWS credentials. This is the glue that allows kubectl to work without any hassle. I've already created an IAM user named EKS API, which has full permissions to our Kubernetes components. You might be wondering how the AWS CLI commands are authenticating. When I created the IAM user, it provided me with an access key and a secret key. I already exported these three AWS environment variables. The access and secret keys are like a username and password respectively. Here's a screenshot of the access key associated with the EKS API user we already created, and we can see the access keys match. We could create a config file, but environment variables work well here, and I'll explain why once we explore the Travis setup. Normally, you would not share this secret key, but by the time you're watching this clip, this IAM user will be long gone. I'm also specifying the default region, so anytime we use AWS CLI commands without specifying a region, it will use US East 1. That's where our Kubernetes cluster is located. At this point, we can run our installation script to install the required packages. We see that kubectl was downloaded and installed successfully. Next, we see the AWS package downloaded and installed as well. This output is from the getCaller identity command, and notice the username of EKS API as expected. This means authentication succeeded. We also see output that indicates the creation of a kubectl config file, which means our update cluster command succeeded also. Now the question becomes, how is Kubernetes going to deploy our custom Flask container? We need to push it up to Docker Hub after it's been tested in Travis. Let's explore a script named push-to-dockerhub.sh that does this. This script also uses environment variables with my personal Docker Hub username and password. The docker login command allows us to log in so that future Docker push commands succeed. After logging in, we apply a tag to our newly built Flask container so that my personal Docker Hub account is associated with the container. You can use your own personal account here if you are following along. Finally, we push the container up to Docker Hub, making it public. I'm not going to run this script locally because it might look like I'm cheating. If we push the image up from our dev box and Travis fails to push its image up, then we might get a false positive. Let's quickly check Docker Hub to ensure that my account doesn't have any existing images. Okay, great, nothing here. I deleted all existing images from my account just to prove that our CI/CD pipeline will work. The last thing we'll do is check the Travis CI repo settings. Okay, this screen should look familiar. We can click on More Options and then Settings to add environment variables to our build process. Let's scroll down a bit to find that section. Using environment variables in Travis is a great way to supply secrets and other information that isn't well suited to config files or source code. There are many ways of handling this, but I find environment variables to be the simplest approach. Notice that my secret variables are hidden. They won't show up in logs or through the web browser. At this point, we're ready to dig into Kubernetes manifests and the deployment process.